Good morning, dear students. Today we are going to solve October-November 2019 1-1 paper. It's a Zone 1 paper. It's an MCQ paper. The course we are studying is Physics 5054. My name is Ferhan Mazher. Let's start today's paper. Which word is the name of a scalar quantity? Acceleration. Acceleration is a vector quantity. Force is a vector quantity. Mass is a scalar quantity. Velocity is a vector quantity. So C is the option. Question number 1, C is the option. Mass is a scalar quantity. Question number 2, what is the size of the resultant of the two forces shown in the diagram? Okay, here we have two forces, 3 Newton, and we have 4 Newton force. The angle between them is 90 degree. Their tails are joined. So we will complete a parallelogram. We will use the parallelogram law to find the resultant of these two vectors. I've done this on a paper. Let me show you that. Okay, so here you see 3 Newton force, 4 Newton force. They are making 90 degree angle with each other. Their tails are joined. So we will use the parallelogram law to find the resultant. So we completed the parallelogram. We suppose that these are the two adjacent sides of a parallelogram. And I completed the parallelogram, the point where the tails of the two vectors to be added, the tails where the point where the tails were joined. I will join that point with the opposite corner of the parallelogram, and that will be the resultant. This is 3 Newton, so this side will be also 3 Newton. This is 4 Newton, 3 Newton. If this angle is 90, this angle will be also 90. So it is a right angle triangle. So apply Pythagoras theorem and find out what is the length of this diagonal. So, you know, according to Pythagoras, perpendicular square or plus base square, 4 square plus 3 square, and we take under root over it. So it's 16 plus 9, 25, under root 25 is 5. So the resultant is 5. So resultant is 5. So C is the choice. Question number 2, C is the choice, 5 Newton. A length of copper pipe of uniform cross-section and several meters long carries water to a tap. Measurements are taken to determine accurately the volume of copper in the pipe. Which instruments are used? You know, this is a hollow pipe, and if you want to find out its volume, you need to know the length of the pipe, and you need to know the external diameter and the internal diameter. For finding the external diameter and the internal diameter, vernier calipers are used, and to find out the length, because several meters long, so we will use tape. So D is the right option, tape and the calipers. D is the right option. What is the correct unit for the quantity shown? Electromotive force. Electromotive force, its unit is volt. They have written here Newton, so that's wrong. Latent heat is measured in joules. That's the right option. Don't confuse it with the specific latent heat. Okay. C is pressure. Pressure is measured in Newton per meter square. And D is weight. Weight is measured in Newton. So everything except the B is wrong. So B is the right choice. That the latent heat its unit is joules. B is the right option. Question number 4. B is the right option. The graph shows how the speed of a car varies with the time. So it's a speed time graph. On the y-axis, the speed is represented. On the x-axis, time is represented. And you should remember that the slope of the speed time graph is equals to acceleration. And if the graph becomes flat, if the graph becomes horizontal, if the slope of the graph becomes 0, it means that the acceleration is 0. The body is moving with the constant speed. Which statement about the acceleration of the car between the time 10 seconds and 20 seconds is correct? From 10 seconds to 20 seconds, you can see that the graph is flat, the graph is horizontal, the slope of the graph is 0. It means that the acceleration is 0. The body is moving with constant speed. Acceleration is 0. So D looks the right option, sir. The acceleration is 0. Question number 5, D is the right option. A car is accelerating along a straight horizontal road. The diagram shows forces acting on the car. Underline this word is accelerating. When the thing is accelerating, there is some resultant force. It means that the driving force and the air resistance, they are not equal to each other. The car is accelerating. Underline this word accelerating. Driving force and the air resistance, they are not equal. That's why we have some resultant force in the forward direction. That's why the car is accelerating. Which forces are balanced? So in the vertical position, the weight is acting downward and the contact force here and the contact force here, they are acting in upward direction. So the driving force and the air resistance, they are not equal to each other because the car is accelerating. So this vertical forces, because neither the car is going upward or the car is not going downward, it means that the weight which is acting downward and the contact forces which are acting upward, they are balanced. They are equal to each other. Total contact forces is equal to weight. So B looks the right option. The contact forces and weight, they are balanced to each other. B, question number 6, B is the right option. A single force is applied to a body. What cannot happen? You know, when the force is applied on a body, its direction of motion can be changed, its velocity can be changed, its position can be changed. The one thing the force cannot do, it cannot change the mass of the body. The force can change the size of the body, the force can change the state of motion of a body, the force can change the speed or velocity of the body, the force can change the location or position of the body, but the force cannot change the mass of the body. So B looks the right option. A change in the mass of the body initially at rest. So what cannot happen? What cannot happen with the force? The mass of the body cannot be changed by applying the force. So B is the right option. Question number 7, B is the right option, sir. Okay. The Earth travels at constant speed in a circular orbit around the sun. Okay, so the Earth is moving in a circular path around the sun. This is the sun, which is the center of that circle in which the Earth is moving. So it has always the resultant force, and the direction of the resultant force is towards the center of the circle. So R is the direction of the resultant force. Acceleration in the Earth will also directed toward the center of the circle. So R is also the direction of the acceleration. The direction of the motion of the Earth and the direction of the velocity is tangential to the circle in which the Earth is moving. So Q is the direction in which the Earth is moving, and Q is also the direction of the velocity of the Earth. Question is, which arrow shows the direction of the acceleration of the Earth and the direction of the velocity of the Earth? Direction of the acceleration of the Earth will be towards the center of that circle. So R is the direction of the acceleration, and the direction of the velocity will be tangential to the circular path. So Q will be the direction of the velocity. So R is the direction of the acceleration, and Q is the direction of the velocity. So D looks the right option, sir. Question number 8, D is the right option. A body slides down a frictionless slope as shown. As the body presses on the surface pushes back on the body. In which direction does the surface push back on the body? You see, this is the normal reaction of the surface. So C is the option. C is the option. C is the right option for question number 9. This is the normal reaction. This is the direction in which the normal reaction of the surface acts on the body. There is no atmosphere on the moon. Two metal spheres of identical volume but different mass are at rest at the same height above the ground on the moon. They are dropped at the same time. How do the sphere move after release? You see on the moon, because there is no atmosphere, there is no air. So when there is no air resistance, when there is no air resistance, when you drop two objects from the same height, they touch the ground at the same time. They take the same time to fall and touch the ground. The two spheres hit the ground together. D is the right option, sir. D is the right option. The two spheres hit the ground together. D, question number 10, D is the right option. What is an expression for the moment of a force about a pivot? The moment of a force about a pivot is force multiply the perpendicular distance between the line of action of the force and the pivot. Moment is equals to force multiply perpendicular distance between the line of action of the force and the pivot. So C looks the right option, sir. Question number 11, C is the right option. It's a simple question. Okay. A student balances a non-uniform object on a pivot. To do this, a weight is suspended near the left-hand end of the object as shown. Where is the center of the mass of the object? You know, because here an extra mass or weight has been hung here. So C is definitely not the center of gravity. Because if this is the center of gravity, then you don't need to, because if the C is the center of gravity, then you don't have to hang a weight here to balance that thing. So because the pivot is under the C and here you have put an extra weight, so it is trying to produce a anti-clockwise moment. To balance it, here the weight should be acting, which should be produce clockwise moment to balance this anti-clockwise moment. So the center of the, because here you have not hung any kind of weight, so naturally here is the center, here is the weight of this whole object acting. So D should be the center of the mass of the object. So D is the option. Question number 12, D is the right option. A load L is suspended from two springs that are in parallel. The extension of each spring is X. You see, this load L is by this rod is hung with these two springs. These two springs are parallel to each other. This load is uniformly distributed on this spring. It means that this load is not, this spring is not experiencing the full load L. It is experiencing only half the load. This spring is only experiencing the half the load. The extension produced in this is X. Extension produced here is also X. The springs are then arranged to hang vertically on one below the other as this. So now this load is fully on this. This full L is also, this load is being experienced by this spring also. So when half the L was hung with the, when the half the load was experienced by the single spring, the extension was X. Now when full load is experienced by this spring, the extension produced will be 2X. And this spring will also have 2X extension. So 2X extension here, 2X extension here. So the total extension will be 4X. A little tricky question. The total extension will be 4X. D is the right choice. Question number 13, D, 4X is the right choice. Nail X is tapped into wood. Nail Y is tapped into the same wood using the same force. Which nail moves furthest into the wood and why? You know, the contact area with the wood of this nail will be very small, and the contact area of this nail with the wood will be larger. You have applied the same force because this contact area is larger, so the pressure produced in here on the wood will be smaller, and here when the contact area is very small, the force is same, so the pressure here will be very large. So X will go farthest, and the reason is that the pressure will be greater on the wood. So X will go farthest because X produces greater pressure on the wood, and the reason is it's the shape here. You see, it's tapered, and the contact area with the wood will be very small. Here, the contact area will be larger as compared to the X. So here, the pressure is greater, and it will go the farthest. So A looks the right choice, sir. Question number 14, A is the right choice. The The list gives the symbols of for some physical quantities: acceleration of the free fall g, atmospheric pressure capital P, density of the water rho, depth of the water h. Which quantity from the list are used to calculate the total pressure at the bottom of the lake? You know, when we calculate the pressure at the bottom of lake, we calculate two pressure. One is the atmospheric pressure plus the pressure due to water. The atmospheric pressure here is capital P plus the pressure due to the water is rho GH. So capital P atmospheric pressure plus the pressure of the water. The pressure of the water is rho GH. So which quantities are used? Capital P, rho, G and H. They all are used. So A looks the right option, sir. A tricky question and a new question. A is the right option. Which graph shows the relationship between the pressure and the volume of a fixed mass of a gas at constant temperature? The relationship between the pressure and volume of a gas at constant mass and at constant temperature, the pressure and the volume are inversely proportional to each other. And remember, the graph which represents the two quantities inverse relation with each other is this. It's a standard graph. It shows the inversely proportional relationship between two quantities. So C is the right option, sir. Question number 16, C is the right option. A heavy box of weight W slides down a frictionless slope. What is the work done by the weight in moving from top to bottom? The work done will be equals to the loss in the gravitational potential energy. You know, the work done formula is the force multiply the distance traveled in the direction of the force. The work done can be loss or gain in the gravitational potential energy. The work done can also be the change in the kinetic energy. So there are different formulas for the work done. So here, because the weight we know W and the vertical height is X. So the loss in the gravitational potential energy is weight multiplied the height. So vertical height, I mean. So the loss in the gravitational potential energy will be weight multiply X, and the work done will be equals to the loss in the gravitational potential energy. So W multiply X. A is the option. Question number 17. A is the right option, sir. Where is the energy released by the fusion of hydrogen nuclei to form helium? This is happening on the sun, on the stars, that the smaller nuclei of helium, they come close to each other, they fuse into each other, and they make larger nucleus of, smaller nuclei of hydrogen, they come and fuse into each other, and they make larger nuclei of helium. Small nuclei of hydrogen, they come close to each other and they fuse with each other and they form larger nucleus of helium. We call it fusion. This is happening on the sun, in the core of the sun, and this is happening on the star. This is the source of energy on the sun. So this is happening in the core of the sun. 18, D is the right option, sir. D is the right option. Which change on its own increase the range of liquid in glass thermometer? Range, underline this word. He's talking about to increase the range. If you want to increase the range, increase the diameter of the capillary, use a liquid who expands less, use less volume of the liquid. So which option is the correct option? C, increase the diameter of the capillary. Don't confuse it with, because most of the time he asks you questions, how to increase the sensitivity of the thermometer. Sensitivity of the thermometer and the range of the thermometer, they basically are opposite to each other. So, but this time the question is not on the sensitivity, but the question is how to increase the range of the thermometer. So here you have to increase the diameter of the capillary. So C is the right option. Question number 19, C is the right option. That will increase the range of the thermometer. C, question number 19, C is the right option. Question number 20, a student is given a thermometer that reads 1 degree centigrade in pure melting ice and 101 degree centigrade in pure boiling water. You know, there is a zero error in the thermometer, and zero error is it's positive zero error. It's giving 1 degree more than the accurate temperature. So on the ice, melting ice, instead of saying giving the reading 0 degree centigrade, it's giving 1 degree centigrade. And in the boiling water, in the steam, it's instead of giving 100 degree centigrade, it's giving the temperature 101 degree centigrade. So there is a positive zero error in this thermometer. She uses it to measure the temperature of some water before and after it is heated. How does the rise in the temperature of the water calculated from her results compare with the correct value? You know, then you will calculate the rise in the temperature. It means you will calculate the difference of temperature, the rise in the temperature. You will calculate the difference, or you will calculate the change in the temperature. So when you calculate the change, you take the final temperature minus the initial temperature. So when you do the subtraction, then the zero error is not in that do not affect the zero error present in the your instrument do not affect when you calculate the change in the reading. If you just measure the temperature, then there is error. But if you use measure two temperature with that instrument, and then you find the change in the temperature, then the effect of the zero error on the change in the temperature, that there will be no effect. Okay, so there will be no difference. If you use a thermometer which has no zero error, and you use this thermometer, when you will calculate the change in the temperature, both thermometers will give you the same calculation. It is the same, because the zero error in the thermometer have no effect when you calculate change in temperature. So it is the same. B is the choice. Question number 20, B is the right choice, sir. What is the name of the change of state that occurs when a substance changes from a solid to a liquid? When a substance changes from a solid to a liquid, it's called melting. Very easy question. It's called melting. 21, D is the right option, sir. A metal rod is heated. What happens to the rod? When you heat a rod, it will expand. Its mass will not change. So its density, which is mass divided by volume, because the mass will be unchanged, but the volume will increase, the density will decrease, because the numerator is the same, but the denominator volume has increased. So the density will decrease. So what happens? The density will decrease, the mass will remain unchanged, the volume has increased. The density will decrease, the volume will increase, the mass is unchanged. So B looks the right option. Its density decreases and its volume increases. B. Question number 22. B is the right option, sir. Okay, let's reduce the size. The diagram shows a glass flask full of water at 10 degrees centigrade. A long glass tube passes through the bung into the water. The water level in the tube is at X. The flask is placed in hot water and the water level in the tube eventually rises to Y. Why does the water level rises? Remember, this question also came in a theory paper also, where you have to write this explanation. Why the level of the water will go up? The reason is when you heated it, the two things, water and that flask, both have expanded. When you heat it, the flask and the water inside it, they both becomes hot and they both expand. But the flask is solid and the water is liquid. So the when you give the rise of temperature, same rise of temperature to the water which is liquid and to the flask which is solid, the solid will have less expansion. The liquid will have more expansion. So the flask, because the idea is if the flask will expand, then the level of the water should go down. But the flask expanded and the water also expanded. Due to the expansion of the flask, the level of the water should have gone down, but the level of the water has gone up. The reason is the flask expanded. No doubt the flask expanded, but the water also expanded. And the expansion in the liquid for the same rise in the temperature is more than the expansion in the solid. So the water expanded more as compared to the expansion in the flask. So when the water will expand, the level of the water in that tube will rise. The flask expands less than the water expands. So D looks the right option, sir. The flask expands less than the water expands. Question number 23, D is the right option. I hope you have understood this description. This question, this same story came in a theory paper, paper 2. And there you have to write that description which I just tried to explain to you. There's an important question. A glass beaker contains water in a warm room. The water is initially at the same temperature as the room. What change does not affect the initial rate of evaporation of the water? Changing the temperature of the water, that will definitely change the rate of evaporation. Using a beaker made of thicker glass, yes, this will not change the rate of evaporation. Using a beaker with a larger cross-sectional area, because larger cross-sectional area, the water will have larger surface area, so the rate of evaporation will become faster. So the C cannot be the answer. Using a fan to blow air over the beaker, that will increase the rate of evaporation. So B is the right option, that it will not change the rate of evaporation using a beaker made of thicker glass. So B is the right option. It will not change the rate of evaporation. B is the right option. Question number 24, B is the right option. The frequency of microwaves used in an experiment is 3 expo 9 hertz. The frequency of the microwaves is 3 expo 9 hertz. Their speed in air is 3 expo 8 meter per second. What is the possible frequency and possible speed in air of a radio wave? The speed of the radio wave is same. All the electromagnetic waves have the same speed in the air. So the speed of the radio wave will be also 3 expo 8 meter per second. Speed of the radio wave will be also 3 expo 8 meter per second. But the radio waves, they are, if you remember that code word for the electromagnetic spectrum, Ronald McDonald is very ugly except Gary. Ronald McDonald is very ugly except Gary. So the radio waves have smaller frequency as compared to the microwaves. Radio waves have smaller, less frequency. I said smaller, it should be less frequency than the microwaves. The frequency of the microwaves in the question is given. You don't have to memorize it. It's 3 expo 9 hertz. So the radio waves will have less frequency. Um, so out of B or the D, B looks the good option, sir. 3x per 5 is the frequency, because this frequency is less than the 3x per 9 hertz, and the speed of the radio wave is also 3x per 8. So B is the right option, sir. You don't have to memorize these numbers. Okay, remember this. You don't. It's just you have to compare them. And one fact you should know, that the radio waves have less frequency than the microwaves. So B is the right option. The diagram shows a ray of light in liquid incident on the boundary with air. The two other rays are observed. One is in the liquid and the other is in the air on the boundary. What is the angle of refraction? The angle of refraction here is, this is the normal here. So this angle, because the ray has started traveling on the boundary of the two medium, so this angle is 90 degree. So the angle of refraction is 90 degree. 90 degree. D is the right option. Question number 26, D is the right option, sir. Light is incident at 90 degree on the surfaces of the two glass prisms P and Q. Here I have two glass prisms. This is the glass prism P. This is glass prism Q. Here the light is entering into this space of the prism. It's making 90 degree angle with the face or the surface of the prism. Here the light is entering in this space of the prism, and it's making 90 degree angle with the surface of the prism. So these are the two prism P and Q. The critical angle for the light traveling from glass into air is 42 degree. So the critical angle, remember this number, the critical angle is 42 degree. Where does the total internal reflection occur? Okay, I've done this on a paper. Let me show you my work. I hope this is visible on your screen. So you see this, because it's entering in the prism at 90 degrees, so it will go undeviated when it will touch on this face. I have drawn here a normal. You will actually do this. Okay, this angle is 90, this angle will be 90, this angle will be also 90. So because it's a 45 degree prism, so if this is angle 45, this angle will be 45. If this is 90, this is 45, this is 45. If this is the normal, if this angle is 45, this angle is 45. It means here the angle of incidence is 45, which is more than the critical angle. So the process of the total internal reflection will take place and the light will go in this way. Okay. This prism is also 45 degree angle prism. Okay. So here the light is entering at the making 90 degree angle with the surface of the prism. So it will go undeviated and it will touch this face here. I have drawn a normal here. This angle is 90, this angle is 90, this angle will be also 90. This angle is because it's a 45 degree prism. So this will be 45, this is 90, then this will be also 45. If this is the normal and this is 45, then this will be also 45. So here the angle of incidence at this point is also, the angle of incidence is 45 degree, which is more than the critical angle. Critical angle was given 42 degree. So because the angle of incidence is more than the critical angle, so the total internal reflection will also take place here. You see the light will not go into the air, but it will be reflected here. So the total internal reflection has taken place in the prism P and the total internal reflection has taken place in the prism Q. So the total internal reflection took place in both the prisms. So very tricky question, you know. ABCD is very easy, but actually how you decided that the total internal reflection took place and how you decided that total reflection took place in the Q, it involved geometry, it also involved the concepts of physics, it also involved the concept that you are using a 45 degree angle prism. So it's a little tricky question. So both in P and Q. A is the right option, sir. Question number 27, A is the right option. A person hears an echo after sound hits a solid cliff face. What causes the echo? Echo is produced when the sound waves are reflected from a rigid surface. So by the reflection of the sound waves. So C is the right option. Question number 28, C is the right option, reflection of the sound waves. What is the typical value for the speed of the sound in air? The speed of the sound is 330 meter per second in the air. 330 meter per second. This number, we know this number. And on your screen, you know, 330 meter per second is the speed. If I want to convert it into the centimeter per second, in 1 meter there are 100 centimeters, so I multiplied with 100. So 33,000 centimeter per second. In exponential form, it will be 3.3 expo 4 centimeter per second. 3.3 expo 4 centimeter per second is the speed of sound in air. 3.3 expo 4 centimeter per second. A is the right option, sir. It's a tricky question. Very famous concept, which we normally all our students know, but by converting the unit, he had made it tricky. 3.3 expo 4 centimeter per second. It's a new question also. So 29A looks the right option, sir. It's a brand new question. I have never seen this question before. It's a brand new question in the MCQs of the your O levels. Magnets M1, M2, and M3 are joined by iron balls W, X, and Y as shown. So these are magnets, okay? So these are the magnets. Magnetic poles are induced on the iron balls W and X as shown. So here we have south and south, here is south and south, and here we have north and the south. So which diagram shows the poles induced in the ball wire? It's a typical question which involves the on the spot, the presence of mind. The question is easy, and we have never done this before. If you do practice from 2002 to 2019, you will never find this question in MCQ. This is a brand new question. Okay, I've done this on a paper and it will make your work easy. See the trick? He has shown this, south-south. He has shown this, north-south. He asked you a question about this. So here we have a south. So what should be here? North. If here you have a south, what should be here? North. So this is the thing he asked you. So it should be north, north. It's easy, very easy, but it needs presence of mind. North, north. So the B is the option. The B is the right option. Question number 30, B is the right option, sir. It's a good question, okay? Brand new question. Question number 31. The base of a cloud is negatively charged. The cloud is over a metal mast as shown. Which row describes the charge induced at the top of the mast and how it is produced? Okay, you know this bottom of the cloud is negative. So what will happen? All the electrons here, they will be repelled and they will go down to the earth. And the top of the mast will become positive. The top of the mass will become positive because the repulsion due to these negative charges, the electrons here, they have moved down. So the top of the mass will be positive, and the reason is that the electrons are moving to the bottom of the mast. So C looks the good option, sir. Question number 31, C is the right option. The charge on the top of the mass will be positive, and the reason is the electrons from here have gone down. They have moved down. So C is the right option, sir. Okay. An aircraft flying through the air becomes electrically charged. What causes this to happen? This happens because when the aircraft is flying, due to the air friction, the charge is produced on the surface of the aircraft. Friction of the aircraft with the air. Yeah, that's the reason, sir. B is the right option. Very simple and easy question. B is the right option. Question number 32, B is the right option due to the friction, air friction with the body of the airplane. So B is the right option. A new question again, and a tricky one. An AC supply connected to an oscilloscope produces the trace shown. So this is an AC supply. So this is how AC supply is represented. It's a sinusoidal wave, a wave which goes up and down and up and down, sinusoidal wave. We call it sinusoidal. A diode is now connected in series to the circuit as shown. So when you connected a diode here, and here you have connected the, your CRO. When you connect the diode will let the current flow in one direction only. But here you have connected the alternating power supply. The alternating power supply provide the current in both the direction. So the current flows in this direction, and then the current flows in this direction. This is alternating current. Now you see, when the current will flow in this direction, the diode will be, the direction of the diode and that current will be the same. The diode will be forward biased, and the diode will let the current flow. So here the voltage will be shown. But when the current will flow in this direction, it is the direction of the current will be opposite to the direction of the diode. The diode will be like the backward bias. So the diode will not let the current flow. So the voltage shown here will be 0. Okay. So when the current will flow in this direction, the voltage will be shown here. When the current will flow in this direction, the voltage shown should be 0. The voltage used by this resistor should be 0, I mean. So the voltage will be used, and then 0 voltage, then again will be used. And the wave should not come down, because now the voltage EMF is only in one direction. So A looks the best option. It's a little tricky question. Very tricky question. A looks the right option, sir. Question number 33, A is the right option. A little difficult concept. Resistors of different resistances are connected to a power supply in either a parallel circuit or a series circuit. Which statement is correct? The current is the same in all resistors connected in parallel. That's wrong. Voltage drop is same in all the resistors which are connected in parallel. Current is not same. The current is the same in all resistors connected in series. That's true. That's 100% correct. When you connect the resistors in series, because the current has only one loop, the current has only one path, so the same amount of current flows through them all. So the current in all the resistors is same. So that's the right option. B is the right option, sir. The voltage across each resistor is different for all the resistors connected in parallel. That's wrong. The voltage across each resistor is the same for all the resistors connected in series. That's also wrong. So B is the right option. The current is same in all resistors connected in series. So B is the right option. Question number 34, B is the right option. An ammeter is connected to 3 resistors and a power supply. Which arrangement of resistors give the greatest ammeter reading? Ammeter gives you the reading of the current, and the current from the battery will be maximum when the resistance of the whole circuit is minimum. And when the resistance of the whole circuit can be made minimum, how you can make the resistance of the whole circuit minimum? When you connect all the resistors parallel to each other. You don't have to do the calculation here. It's just a conceptual question. If you connect all the resistors parallel to each other, the total resistors of the whole circuit will be minimum. When the total resistance of the whole circuit will be minimum, the current coming from the battery will be the maximum, and the ammeter will give you the greatest reading. It's an easy question. It's a conceptual question. So where all the resistors are connected in parallel to each other? Diagram A. So A is the answer, sir. Question number 35. A is the right option. Here, A is the right option. You don't have to calculate anything here. A lamp is connected to a mains plug. Where are the switch and the fuse connected so that the lamp is safe to use? The fuse and the switch, they both are always connected in the live wire. The switch should be connected in the live wire. The fuse should be connected in the live wire. So A is the right option, sir. Question number 36, A is the right option. The switch should be in the live wire and the fuse should also be in the live wire. It's a fact, you should remember this. The input voltage of to a transformer is 24 volt. So the output voltage is 6 volt. The input coil has 720 turns. How many turns are on the output coil? Remember, we have an equation for the transformer. NS divided by NP equals to VS divided by VP. Let me show you. Okay, famous. NS divided by NP equals to VS divided by VP. NS means the number of the VS is 6, and here I have made a mistake. Okay, in writing I made a mistake. So this is NS actually. This is not VS. It is NS. Okay. So the voltage in the secondary are 6. The voltage in the primary are 24. The number of turns in the secondary. Please mark this mistake. This is not VS. It is NS. Number of turns in the secondary. That's question. And the number of turns in the primary are 720. So this is NS. Number of turns in the secondary. They are 6 into 720 divided by 24. 180. VS 180. This is NS. Number of turns in the secondary are 180. It's a step down transformer. So B is the right option, 180. B. Question number 37. B is the right option. And I told you, let me show you if I can do this. We don't have a, how I can show you. This is a mistake, okay? This should be NS, okay? NS, yeah, number of the turns in the secondary. By mistake, I wrote VS, okay? Okay. So 180 is the answer. A student suggests 4 conditions for the production of a continuous flow of electrons from a metal filament. For the continuous flow of electrons from a metal filament, that the metal should be hot. There should be low gas pressure inside, and there should be a very anode which is at very high voltage. A filament is hot. Yes, this is the requirement. High pressure gas is present. No. A high positive electrical potential is present. Yes, 1 and 3 are correct. A strong magnetic field is present. No. Which of the four conditions are needed? Which of the four conditions are needed? We need one and third. C is the right option. We need hot filament, so the thermonic emission can take place, and we need an anode which is at very high potential. Anode is positive. So one and third. C is the right option, sir. The diagram shows the trace on an oscilloscope screen when connected to a DC supply, which is being switched on and off. The settings of the wire gain control and the time-based controls are shown. So this is the wire gain setting. It is set on 2. It means that one vertical deviation is equals to 2 volt. So how much it goes up and then comes down? You see, it goes 2 squares up. So the 1 square here vertically represents 2 volts. So it goes 2 squares up. So 2 multiplied 2, the voltage is 4 volt. The voltage is definitely 4 volt. Now, this is the wave. This is the shape of the wave. Let me show you. See, so the time-based setting is 0.01. To complete one wave, here the one wave is completed. You see, this is the one wave. This is the second wave. Okay. So the one wave horizontally, it has taken 2 squares. So 1 square horizontally represents 0.01 second. 1, 2. So the time period is 0.01 multiplied 2, and the time period is 0.02 second. But the question asked is about the frequency. So the frequency is equals to 1 by T. I have done this on a paper also. Let me show you. Reduce the size so you can see the whole question. So V is equals to 2 multiplied 2 because vertically its amplitude is 2 squares. 1 square is 2 volts. So 2 squares will be 4 volt. So the voltage is 4 volt. The time period, the horizontal for one complete wave, there are 2 squares horizontally, and 1 square from the time-based setting we know represents 0.01 second. So 2 multiplied 0.01 is equal to 0.02 seconds. So I know the time period, and you know the frequency is equal to the reciprocal of the time. F is equal to 1 by T. So 1 divided by 0.02, and the answer will be 50 hertz. So the voltage is 4 volt and the frequency is 50 hertz. 4 volt and 50 hertz. So C looks the right option, sir. Voltage is 4 volt and the frequency is 50 hertz. I hope you have understood that from this graph we were able to tell the time period, and from the time period I was able to calculate the frequency. A little bit tricky question. Okay. A narrow beam of radiation from a radioactive source travels out of the page through the point X. The poles of the magnet are placed on either side of the beam. Radiation is now detected both at X and at Z. Which type of radiation are present in the beam? You know, it's a brand new question on radiation. I have never seen this MCQ from 2002 to 2019. So this is a brand new question. So you see the radiation, when there was no magnetic field, the radiation was coming out at point X. But when you applied the magnetic field, the radiation was coming through 2 points, one at the X and one at Z. So it means there are 2 kinds of radiation. One is that kind of radiation which is not being affected by the magnetic field. So which radiation is not affected by the magnetic field? Gamma rays. Gamma rays are not affected by the electric field and the magnetic field. So the one radiation which is definitely present and which is coming at point X after applying the magnetic field is gamma rays. The gamma rays are there. Okay. And at the second point where the radiation after application of the magnetic field is coming out is Z. So there is some radiation which after application of the magnetic field has deviated. It has deviated from its path. So it could be beta, it could be gamma, it could be alpha, sorry. Alpha are positive, so they are deflected in the magnetic field, and beta, they are negative and they are also deflected in the magnetic field. So we will apply the left hand rule and try to see what happens. You see, this is your left hand. Go to your left hand and stretch the fingers of these three fingers of the left hand in such a way they are mutually perpendicular to each other. Fleming's left hand rule you must have studied. FMC, FMC, and remember this is about the positive charge. Okay, so the charged particles are coming towards me or you, and the magnetic field is from left to right, from north to south. My thumb is pointing upward. So this radiation should have deflected upward if it was positively charged. If it was alpha, alpha has positive charge. But it has deflected downward towards Z. It is not positively charged. It's definitely negatively charged. So it's beta particles. So this sample is giving out gamma radiation and beta radiation. So D is the choice. D is the right choice. Question number 40, D is the right choice. It's a brand new question and it's tricky because it involves the concepts of the radiation and it also involves the use of the Fleming's left hand rule. So we are at the end of the question. During this question, when we were doing this question, this paper, sorry, and I was doing my written work, I made a mistake. I told you that, let me tell you again, that when I was doing this question by mistake, here I should have written NS, number of turns in the second required. Here I should have written NS, here I should have written NS, number of turns in the second required. So when you do this, kindly rectify this mistake. Otherwise the numbers are good. So everybody, thank you very much. Today we have done October, November 2019 1-1 paper. It's a MCQ paper. It's variant 1 paper. And the course we are studying is Physics 5054. My name is Ferhan Mazher, and I hope that these videos are helpful to you and they are helping you to improve your concepts of physics and to improve your grades. Thank you very much, everybody. Have a good day and God bless you all. Thank you very much.